moon. One of the reasons the J140 they call it Super Saturn, also known as Saturn on steroids, or the true Lord of the Rings. Its real name is J1407b, and the world is truly extraordinary. Super Saturn is a massive exoplanet about 434 light-years away from us in the Centaurus constellation. This planet is surrounded by, so far, the largest known ring system in the universe, making Saturn feel puny. The first observations of J1407b were made in 2012 by a team of astronomers led by Eric Mamajek from the University of Rochester, using data from the SuperWASP project, a survey that's designed to detect gas giants that move in front of their parent star. These observations revealed that the exoplanet had a massive ring system that was about 200 times larger than the rings of Saturn. The rings were estimated to be more than 200 times as large as the rings of Saturn and contained an enormous amount of material, roughly equivalent to the mass of Earth. The team proposed the rings were caused by a moon-forming disk around a young giant planet or brown dwarf. In 2015, a team led by astronomer Matthew Kenworthy of the University of Leiden took another look at the data and showed that the ring system consists of over 30 rings, each of them tens of millions of kilometers in diameter. They also found that the ring system had a series of gaps and variations in density, which indicated the presence of exomoons orbiting within the ring system. Scientists noted that the planet's parent star was too far away to observe the rings directly, but they were able to make a detailed model based on the rapid brightness variations and the starlight passing through the ring system. They used these models to see how the exomoons might be affecting the ring system and found that the moons would be causing the gaps in the rings by clearing out the material in their orbits. They were also able to estimate the size and mass of the moons based on the size and spacing of the gaps. This was strong evidence for the existence of exomoons, which was a significant discovery. Very few have been directly detected. The researchers explained that the observed eclipse lasted for several weeks and that they noticed rapid changes on timescales of tens of minutes as a result of the fine structures of the rings. The ring system of Super Saturn is 120 million kilometers, 74 million miles in diameter. For comparison, the average distance between the Earth and the Sun is about 149.6 million kilometers, 92 million miles, so this ring system is almost the distance between the Earth and the Sun. If you were to travel at the speed of light through the J1407b ring system, it would take you about 6.7 minutes to cross it from one side to the other. For comparison, it takes about 8 minutes for light to travel from the Sun to the Earth. If we replace Saturn's rings with the rings around J1407b, they would be easily visible at night with the naked eye and would be many times larger than the full moon. One of the reasons the J1407b ring system is so large is that the planet is a massive gas giant, most likely in the range of about 10 to 40 Jupiter masses. This means that the planet's gravity is strong enough to hold onto a massive ring system. One of the most likely explanations for its enormous and very dense rings is that J1407b is very young, and a lot of its ring system will likely coalesce into moons in time. But then, there might also be a very powerful magnetic field at play that helps prevent the ring debris from forming into satellites, but that's pure speculation. Based on the current data, it's expected that the rings will become thinner in the next several million years and eventually disappear as satellites form from the material in the disks. The discovery of these rings strongly supports what the planetary science community has theorized for decades, that planets like Jupiter and Saturn would have had, at an early age, disks around them that then led to the formations of moons. The exact process by which Saturn's rings formed is still not fully understood, but scientists have proposed several theories based on observations and computer simulations. One theory is that Saturn's rings are the remnants of a moon or other celestial body that was torn apart by Saturn's gravity. This theory suggests that the rings were created relatively recently, perhaps within the last 100 million years, and that they will eventually disappear as the remaining material either falls into Saturn or is ejected into space. Another theory is that the rings are the result of a collision between two moons or other bodies in the Saturnian system. This theory suggests that the rings may be much older than previously thought, perhaps as old as the solar system itself. A third theory is that the rings are the result of material that never fully coalesced into a moon or other object, possibly due to the gravitational effects of nearby moons or other factors. This theory suggests that the rings may be much younger than the other theories suggest, perhaps only a few million years old. While these theories differ in their details, they all suggest that Saturn's rings are the result of some kind of disruption event in the past that scattered material into orbit around the planet. A similar scenario might have happened with J1407b. One of the reasons studying ring systems is worth it is that it can help us better understand planetary formation, because ring systems are thought to be the remnants of the formation process of planets and moons. Studying ring systems can also lead to the discovery of new moons or other planetary bodies. For example, thought to be the remnants of the Cassini spacecraft's observations of Saturn's rings led to the discovery of several small moons that had previously gone unnoticed. Studying ring systems can also help improve our understanding of our solar system and different exoplanet systems. Don't forget to watch the video on the right and subscribe. Thanks.